let's get started with this session. And what we are going to look at in today's session is the compound interest and simple interest piece. Along with this, the questions that students find challenging are installments question. And that is where I wanted to talk a bit more from a perspective of installments. And that is the reason why you see so many questions being present over there, right? As usual, I'll start with briefing you about what kind of concepts you need to be aware about before you sit for such a session. And then I'll give you a quick brief of installments as a topic. And then I'll spend more amount of time and energy on the questions and solve those questions for you and make you understand that this is even installments is not going to be very, very tricky if you understand the basic concepts right. I hope all of you have solved the exercise sheet. I hope you are using all the content that we are giving you on the 50 days to CAD community group. Please use that to your fullest, to its fullest, and I'm sure that will add a lot of value and score to your exams. Okay, so let's move on and let's understand your piece of simple interest, compound interest. Now understand this thing that simple interest, compound interest is primarily dependent upon the concept of percentages and the usage of percentages. So understand this thing that simple interest and compound interest are primarily same. The only difference is for every term's calculation of interest, the principal changes. That's the only difference between simple interest and compound interest. Also, one more thing that I want to bring to the notice of all of you is that if you are not using the successive percentage change formula or approach while solving the compound interest problems, you will never be able to enjoy this particular topic. So in my classes, time and again, I've mentioned this thing that if you are avoiding successive percentage change and then trying to do simple interest and compound interest, you are never going to like the topic. This topic will become a nightmare for you because you will feel that there are so many calculations. Okay, so understanding of percentages, number one, that is required on this. Second thing that is required is an understanding of successive percentage change that is required. And then a basic understanding of how money works and the growth and all of that. So let me quickly make you understand. Let's say, suppose if there is a principal value X and you grow it at a rate of 10% for 3 years, and that's a simple interest calculation. So what are you going to do? For every year, you are going to charge a 10% of the principal value. And for how many years are you going to charge this? You are going to charge it for 3 years, and that becomes your simple interest value. But in case of compound interest, what happens is that the same money, which is the value X at the beginning of the first year, increases by 10% in the first year and becomes what? 1.1 times of X. Then if you take this particular value, it again increases by 10% and becomes what? It becomes 1.1 times of 1.1x. And this particular value will again increase by 10% to become what? 1.1 times of 1.1 times of 1.1x. So effectively what is happening is that your money X, which is right now over here, is simple interest being 0.3x and the final amount is being 1.3x. That is the final amount in case of simple interest. In case of compound interest, it is going to become 1.331x. So that's the basic understanding of simple interest and compound interest. I hope we all are clear with this. Now, post this, we will try to have a look at how installments work. There are two ways of looking at installment. I'll put across both the approaches. And then there's one particular approach that I believe is more feasible towards solving the questions faster. So that's something that we will discuss. So let me remove all this and let me talk about the next understanding, which is of installments. So let's say suppose a 10,000 rupees was I taken as an principal amount, and I want to return this in 3 equal installments. Suppose I take each of the installments as X. Okay, and the rate of interest at which this was given to me was, let's say, 10%. If this is the case, then what happens? There are two ways. At one particular point in time, your value of this particular money and your installments must be equal. What do I mean by this? Let's pay attention to this. Now, one thing that I can do is I can bring this value of X back to this time frame and say that whatever is the value of this X and x over here at this particular time must be equals to 10,000. Or what can I do? I can take this 10,000 over here at the end of the 3 years, take this x at the end of the 3 years, and take this x also at the last point, and take this x also. The value of these money at the end must also be equal to 10,000 for 3 years. Now let me show you what do I mean by this. Now 10,000 at the end of 3 years, or let's say I start with 10,000, and let's first look at increasing this particular money for 3 years. So this is going to become what? 1.1 into 1,000, or let's say 10,000. I'm just giving you one example. This is not related to this. I'll come back to this example a little later. Now 1.1 times of 10,000 is what this value will be. Next, it will become what? 1.1 square into 10,000. And at the end of the third year, it will become what? 1.1 cube into 10,000. Now understand this thing, that if I want to bring this particular money back to 10,000, then I will have to divide this value by 1.1, isn't it? If I have to bring this value back to this, I will have to divide it by what? 1.1 whole square, correct? And if I have to check the value of this money at the present time, then I will have to divide it by 1.1 whole cube. So this money, when taken forward for 1 year, was multiplied by 1.1, was taken forward for 2 years. The value of this particular money after 2 years at a rate of 10% would become 1.1 square into 10,000. And at the end of the 3 years, it will become 1.1 cube into 10,000. When I want to bring it back, I will have to divide it by 1.1, 1.1 square, and 1.1 whole cube. Now, keeping this in our mind, we will try to look at this particular example. So let me remove this and let me talk about it once again. So instead of 10,000, let me take 1,000 rupees of loan, and I will return it at the end of with 3 equal installments at a rate of 10%. At a rate of 10%. Now, let me bring this money back into this time into this time period. So what will I do? I will divide x by 1.1. Correct? So this will be the value of this money which I'm going to pay after 1 year in the present moment. Clear? What about this money in the present moment? This money in the present moment is going to become x by 1.1 whole square. What about this money in the present moment? It is going to become x by 1.1 whole cube. Clear with this? Now, in the present place, what is the amount of money? That was 1,000. Clear with this? Solving this equation, you will get the value of x, which is the installment balance. Clear? Now, I'll suggest you the second approach, which I feel is slightly better in terms of calculation, although both of these calculations will lead to the same point. I would want you to bring down the entire money, all 4 money at the end of 3 years, and then equate the two. So what will be 1,000 at the end of 3 years? It is going to become 1,000 into 1.1 whole cube. Clear? What about this x at the end of 3 years? It has got a period of 2 years now, correct? So that is x times of 1.1 whole square. What about this money at the end of the third year? It is x times of 1.1. And x was the amount at the end of the third year, right? Because this installment was paid at the end of the third year. So third year and its value will be x only. Now solving this equation or this equation, you are going to get the value of x. I believe that the second equation turns out to be a lot easier for you to solve, because this is 1.1 whole cube. Should it not be equals to 3,000? Shriram, why will it be equals to 3,000? It is a compound interest that we are talking about, right? And why will it be, from where are we taking it as 3,000? I have no idea. So take that value as x common. You will get what? 1.1 square plus 1.1 plus of 1. If you solve this, you are going to get your answer. In fact, if you look at the first equation, you will realize that first equation will also come down to the same point like that of this. So if you take 1.1 as the LCM on your left hand side, what are you going to get? You are going to get 1.1 whole square into x plus 1.1x plus x, which is equals to 1,000 into 1.1 whole cube. Correct? So could you repeat the method 2 for the equation? Achay, I'll repeat. Just give me some time. So now if you look at this, is it not coming down back to this particular format? Yes, it is coming down back to this particular format. Achya, understand we don't calculate the interest on the installment, then why are we multiplying? I think I've got too many doubts over here. Okay. Okay. Let me take one more example and try to show it to you so that we are better able to understand. I think I've got too many doubts at this moment, but try and understand from a concept of money and how present value of a future money is. That is also something that is important for you to understand. Okay. So I hope some of you would have understood what am I trying to say. Those of you who have not understood, I'll try to take one more shot at it and explain it to you. And then when we'll move on to the questions, you will understand how this really works. So let me just take one more example. There's nothing else that I can do. I will have to take the same example and explain it to you. So let's say if you have 1000 rupees, okay? And at the end of 3 years, what will be the value of this at a rate of 10%? At a rate of 10%, what will be the value of 1000? Take this 1000, increase it by 10%. It will become what? 1.1 times of 1000. That will be the value at the end of the first year. What will be the value at the end of the second year? The value at the end of the second year will be 1.1 into 1.1 into 1000. That will be the value at the end of the second year. What will be the value at the end of the third year? 1.1 into 1.1 into 1.1 into 1000. This will be the value. Clear? So the value at the end of 3 years will be what? 1.1 whole cube into 1000. That will be the value at the end of third year. Clear? Now, look at this value x and x. Now, this was paid at the end of the first year, right? I am taking this money at any point. You can take it at the beginning also, at the ending also, at the end of the first year also, bring everything back to at the end of the first year. This will work out. Take the money at the end of the second year, everything at the end of second year. That will also give you the correct equation, and take everything at the end of the third year also. It is also going to give you the same thing, right? Only rate of interest is something that you will have to be careful about, and that it is growing or decreasing at what rate. That is important. Okay. Now, I've taken 1000 at the end of 3 years and it has become this much. Can you tell me this x at the end of the third year will become how much? This x will grow by 10% for 2 years, right? This is 2 time periods, 2 years, 10% each. So it is going to become what? 1.1 square into x. What about this x at the end of next year? It is going to become 1.1 times of x. What about this x? This was paid at the end of the third year only. So this value of this x will remain x only. Now, what am I trying to say is that value of the installments at the end of the third year and the value of the original money at the end of the third year has to be same. That's the basic concept, right? So this is the value of all the installment by the end of the 3 years. And this is the value of your original money at the end of the 3 years, which is going to be 1.1 whole cube into 1000. This equation has to hold good. Now, you might want to say, sir, I want to bring this back to this. I want to bring this back to this. And I want to take this back to this forward by 1 year. Will this equation work? Yes, it will work. It will work in every scenario. What am I trying to say is, if you take it at this moment, your life becomes a lot easier. This is all what I'm trying to say. So a few of you had some doubts on it. I hope you are clear. Just quickly give me a thumbs up if you are clear with this. Animesh, don't get stuck with that particular concept. Just try to learn this particular concept that I'm looking at the value of money by the end of a certain period. I know where you are coming from. You are coming from the concept that we have used in our book material, and you are trying to visualize it and compare this with that. Please don't do that. It is not going to get you any value out of that, right? Try to look at it from a fresh perspective, that I am taking this money and trying to equate it with the value of the installment at the end of 3 years. That's all. To all of you who were trying to compare it with the previous values, I hope you are clear. Any further doubts, anyone? None. Fair. Let's move on to the questions. The simple logic is take the installments, all 3, 4, 5, 6, 7 installments, take the value of that at the end of the entire period, and take the value of the original money at the end of the entire period, equate the two, you will get your values of the variable. Nothing else is what you are supposed to do on these questions. Let's look at the first question. And over here, the only thing that you have to be careful about is this is simple interest. So I'll talk about it. Take a minute, read this particular question, and then we move on. Those of you who have not paid attention to this simple interest, please pay a close attention to this simple interest. Quite a lot of you have gotten incorrect answers. Okay, let's have a look at this particular question and we will try to look at it from a perspective of simple interest. Now 8750 was lent out. Remember, this is not compound interest, this is simple interest. At a rate of 10%, at a rate of 10% per annum, is to be settled in two equal installments. So one installment is X and one installment is X. This is simple interest of 10%. What will be the value of 8750 at the end of 2 years at simple interest? 8750 at simple interest will grow by 10%, 10% each year. Principal is not changing. 10 plus 10 will become what? 20. So it will become 1.2 times. Had this been compound interest, it would have become 1.21 times. Now take this value X at the end of this time period. What is going to happen? It is growing only for 1 year. So that is 1.1 times of X. And this value X will remain the same because this installment was paid at the end of the second year only. So this value will remain X. So what are we going to get? We are going to get 2.1X is equals to 8750 into 1.2. Clear? So 8750 into 1 into 12 by 21 into X should then give me the answer. 3 sevens are 21, 3 fours are 12, and 7 ones are 7, 7 twos are 14, 7 fives are 35. So X will turn out to be equals to 5,000. Now understand this thing. Those of you have taken 1.21 over here, you have made a fundamental mistake of not understanding this particular point of simple interest. As simple as that. Any doubts, anyone? Quite a lot of you have gotten down to 5250. You need to understand that that was simple interest and not compound interest. Any doubts, anyone? Anand, it is very difficult for me to explain you the first part, what I was trying to explain it to you because the entire crowd has moved on. If it is this question, then just say yes. If it is only about this question. The concept bit, I will not be know the first part of this question. Okay, now understand 8750 was lent out on simple interest, right? It is not compound interest. So when you look at 8750, what will be the value at simple interest at the end of 2 years? It is going to grow by 10% of 8750 for how many years? 2 years, correct? This will be the simple interest. Amount will be nothing, but you will have to add 8750 to this. So this is basically becoming 20% of 8750 plus the amount to it will make it 1.2 times of 8750. That's the first part. Soumya, how is it 2.2? 1.1 plus 1 is 2.1 and not 2.2. Shriram, there is no X part in this. No, this was paid at the end of the first year. I'm looking at the value at the end of 2 years, correct? At the end of 2 years. So this particular money will grow by only 10%, right? Because it is only for 1 year. It was paid at the end of the first year. So it stays, so it is growing for the second year alone. This was paid at the end of the second year. I'm looking at the value at the end of second year. That's all. So X grew by 10% for the first year, becomes 1.1X, and the value X will remain X only. So 1.1X was paid at the end of the first year and was paid X was paid at the end of the second year. No, Nishant, 1.1x was not paid at the end of the first year. Please do not try to look at it from a concept of what was paid at the end of the first year, what was paid at the end of the second term. Look at it from a concept of trying to equate the value of money, value of the installments, and the value of this money at the end of 2 years. That's all what we are talking about. Can we calculate the total amount and divide by the number of installments? Shivam, that's not correct. That is not going to give you the same value. X is nothing but the installment value that you are paying at the end of the first year and at the end of the second year. Achieve, if time permits, I'll come back to this. Let's try question number 2. And this is where your entire compound interest piece will come into picture. And from here on, it will be compound interest. Try question number 2. Take your time. Take a minute's time quickly. All of you have given me the correct answers. Let me have a look at this. And once again, I will try to spend more time on this question. A sum of money 7280 was borrowed at the rate of 20% compound interest is to be paid back in 3 annual installment. So you have taken 7280. You have paid X as the installment at the end of the first year, X as the installment at the end of the second year, and X as the installment at the end of the third year. And with that, you have closed the entire transaction. What will be the value of 7280 at the end of 3 years? 7280 multiplied by 1.2, sorry, 7280 multiplied by 1.2 for 3 years, correct? This will be the value of this money at the end of the third year. What will be the value of X at the end of the third year? It will grow by 20%, 2 times. So it will become what? 1.2 square into X. What about this X? This is going to increase by 20% only for 1 year. So it will become 1.2 to the power of 1 into X. And this X will be the money at the end of the third year. Correct? Because that is paid at the end of the third year. So it is not going to grow for any time. So that value remains X only. Now you just have to solve this particular equation. Take your X common. 1.2 square. I hope all of you are clear that this is going to be 1.44. This is going to be 1.2 and this is going to be 1. And this is 7280 into 1.2 whole cube of this. So this is going to be what? 3.64 times of X. Correct? So 3.64 times of X is 7280 into 1.2 whole cube. This is what we are looking at. Now, if you just solve this 7280, now in your CAT examination, you will have your calculators with you. You can perform such a calculation over your calculator. That is not a problem. 364, and I've taken 100 in the numerator. 364 into 2 is 128. So this is going to be 2000 into 1.2 whole cube. This is the value that you are going to get, and that will come down to 3456. I hope we all are clear. Any doubts, anyone? These equations and this understanding of value of money at the end of certain period, or what is the value of future money in the present moment, is something which is going to be taught to you in your first year of MBAs as well. That's the time value money concept is what they call it. I hope all of us are clear. Any doubts, anyone? Let's move on. Try question number 3. Take your time. Take a minute's time and we move on then. Okay, let's have a look at this. Once again, not a very difficult question. You might find it repetitive, but my problem is that I come across so many students who struggle with this kind of questions of installment. That is why I've kept fair number of questions of installment on today's class, and that is again a repetition of compound interest in itself. A sum of money was lent out on compound interest at a rate of 10% per annum, is paid back in 3 equal installments of 2662. So I don't know what was the amount of money that was lent, but each of the installment was 2662. So I'm taking each of the installments as 2662. Now take this value X, which was the principal value, and calculate its value at the end of the 3 years for 10%. What will be that value? 1.1 whole cube into X. That will be the value at the end of the 3 years. 2662 for how many years? For 2 years it will grow. So then the value that will become at the end of the third year of this 2662 will be 2662 1.1 whole square of this. Next, take this 2662 at the end of the next year is going to be what? 2662 multiplied by 1.1 plus 2662. That's all, right? This solving this equation will get you the value of X. So 2662 common 1.21 plus 1.1 plus 1. So 2662 into 3.31 is what you are getting. Divide that value by 1.331. That is the value of X. So if you remove this decimal and this decimal, you are going to be left with a 0. 1331 into 2 is turning out to be this, and you will realize 6620 will turn out to be the value of X. Gayatri, which part of it you want me to repeat? Understand this value of X at the end of 3 years is going to be 1.1 cube into X. What will be this 2662 at the end of the third year? Because it is going to increase only by 2 years by 10%. So 1.1 whole square into 2662. This 2662 will grow by 10% to 2662 multiplied by 1.1 only once. And this was paid at the end of the third year. So its value is going to be 2662. That's all. Add and equate. Okay. Try fourth. Take your time. Animesh, when nothing is given to you, you are going to take that as compound. All of you have given me the correct answer. Rajesh bought 2500, paying an initial down payment of 1200. So how much is the amount left over to be paid? 1300 is left over to be paid. He opted to pay the remaining amount in 3 annual installments with an interest of 10%. Calculate the value of each installment. So if you take 3 equal installments as X and the rate of interest is 10%, I think this is becoming a bit more repetitive. Let's quickly finish it off. 1300 grew by 10% for 3 years. It is going to be 1300 into 1.1 whole cube. Take this value X, grow it by 10% for 2 years. So X times of 1.1 whole square. This X will increase by 1.1 and this X will remain the same. So a 1 for this. So 1300 into 1.1 whole cube divided by, on the right hand side, 1.21 plus 1.1, which is going to be 2.31 and 3.31. That will be the value of X. No, Sriram, this is not simple interest. This is compound interest. What is giving you the sense that it is simple interest? Clear? So that is going to give you the value of X. If you calculate this slightly tedious calculation, you can always use your calculators, on-screen calculators to do this. You're going to get 523 as the answer. Any further doubts, anyone? Suryansh, there is nothing in case of simple interest. In case of simple interest, this value, would have increased and become a 1.3. That's all. This value would have become 1.2 and this value will become 1.1. That's all. If it is a simple interest. Soumya, we'll come to that. Try question number 5. Take your time. Yes, Ankur, for maths part it is there. Understand it is for months, so compounding has to be monthly, right? If the compounding has to be monthly for every month, month on month, you are going to charge 1% interest. That's all. 12 divided by 12 will give you every month's interest rate, correct? So for every month, you are going to increase it by 1.01. So compounding is going to happen monthly. That's all. I hope, Rajni, that clarifies your doubt. Shriram, I've made a mention of that if it is not mentioned in the question, you are going to presume that to be compound interest. Let's have a look at this. A computer is sold either at 19,200 cash. That means the present value is 19,200 or 4,800 cash down payment. So out of this 19,200, you have made a down payment of 4,800. Correct. So if you look at this, this is going to be what? 14,400 is the loan amount that you are looking at. Together with 5 monthly installments, if the rate of interest charged at 12% per annum, then the amount of each installment will be what? Now understand this thing. 14,400 is the present money. X is the installment paid at the end of the first year. Another X at the end of second month, third month, fourth month, and at the end of the fifth month. I'm sorry, the first one was paid at the end of the first month, second month, third month, fourth month, and fifth month. This is what we are looking at, correct? So now look at this 14,400 at the end of 5 months. As I said, this is 12% per annum. So for 12 months, it is going to be 12%. So for every month, the compounding is going to happen, and that will happen at 1% per month, right? So this particular value of 14,400 will be compounded at the rate of 1% for 5 months. So what will you have? 14,400 into 1.1 to the power of 5, 1.01 to the power of 5. I'm sorry. 1.01 to the power of 5. And now, if you look at this value of X, it will be extrapolated for 4 months at 1%. So I'm taking that X common and making it as 1.01 to the power of 4. What about this X? 1.01 to the power of 3. What about this X? 1.01 to the power of 2. Over here, it is going to be 1.01 to the power of 1, and this X is going to yield a 1. Now, I want you to observe this a little carefully. You will realize this bracket is actually turning out to be what? It is turning out to be a geometric progression. So you can use the formula of geometric progression addition, and you should be able to find the value of this bracket as well. That is also not going to become challenging for you because you will have your calculators available with you. So 14,400 into 1.01 to the power of 5 and x times of, so take 1 as your first term and then the common ratio is 1.01. Okay. So a is 1, r to the power of n. Now 1.01 to the power of 5 minus 1, r to the power of n minus 1 by r minus 1. That is the addition formula for the common ratio for the geometric progression with a common ratio greater than 1. So this is what you are going to get. The denominator is going to become 0.01. So that is yielding 100 there in the numerator. So you have 100x into 1.01 to the power of 5 minus 1. And this is going to be 14,400 into 1.01 to the power of 5. This calculation is something that you will have to perform on the calculator. There's nothing else that we can do about this. Okay. So can any one of you perform this calculation? A 00 gets cancelled out with this. And you can let me know what is the value of x. Can you quickly conclude this? Suryansh, I hate this when says that, can this be remembered? For every kind of formula, you remember something, then you will, for every kind of question, you remember something, and then you get into the paper with 300 formulas in your head. You're not going to ever do the question well. It comes approximately to 2965, 2966 or 2965. The options will not be as close as 1, but they might be slightly close. But people have got 3016 and 2896 also as the answer. Please be very careful. I hope all of us are clear. The questions are not at all difficult to my mind. They are very, very doable, provided you understand the concept of value of money at any given point in time when the rate of interest is given to you or rate of increment or decrease is given to you. Clear? Now this question, I had forcefully kept this on the exercise sheet. And I did this because I wanted to show you what CAT is really asking you. This is a 2018 question. So you can understand what level of question is present on the paper. Take a minute and try this out. Aviral, I'm not sure raising it to the power of 1 by 12, but it is not going to be 1.12. It is going to be 1.01 because that 12 percentage is for an entire year. Monthly compounding, if you do, you divide the rate by that many number of terms, right? So how many terms will be there? 12 terms will be there. So 12 divided by 12, for every month you are going to get 1 percentage. Rishika, no conclusions to be drawn, please. I know where this argument is headed to, and I don't want to take it there. By the way, 2018 paper, people called it as a difficult paper. It was a paper which was a 3 hours paper with each of the section being for 1 hour. Quickly finish it off. No big deal. Okay. The whole explanation that they've given you, the loan was repaid in 2 equal installment, the first after 1 year and after the second year. This particular piece, the first installment was interest and 1 year of interest plus a part of the principal. That is one way of interpreting your installments. So the first installment that you give, you take the entire principal, calculate the interest for the first year, pay that entire interest, and the leftover part after paying the interest has to reduce your principal, bring it lower for the second term. This is generic statement. It has got nothing to do with the question you are looking at, and it happens in every installment. So they are just trying to explain you what do you mean by installment. That's all, nothing else, right? John borrowed 2,10,000 rupees. 2,10,000 rupees from a bank at 10% compounded annually. The loan was repaid in 2 equal installments of X and X. 2,10,000 into 1.1 to the power of 2, and x need to be increased by 10% for 1 year. So 1.1x plus x, that's all. So it is going to be 2.1x, and this is going to be 2,10,000 over here, and 1.21. Divide that value by 2.1 by removing this 2.1 from here, put a 0 extra, and you will get a 1 lakh over here. And this is going to be 1,21,000 as your installment value for each year. Now, can you imagine that this is a question in a 1-hour paper? And on CAT 2018, I distinctly remember people coming back and cribbing about that paper, that paper was really difficult, right? Understand the concept better. So was that last 3 lines just there to for confusion? Shubhat, that's not for confusion. That's an explanation of how installments work. That's as simple as that. So doesn't the second part create confusion? No, it does not. Tejeshwar, no, it is not given for you to confuse you. Yes, Suryansh, that's in your mind that you are making it simpler. For some people who do not understand installment, they will understand from this definition what installment is during the paper. So they want to create a level playing field that somebody who has not thought about installment and can sit over there in the exam and can make sense out of this is also a very good student for us. They typically do this thing that when they don't expect you to know something, they explain it in the paper. And rather than be people pointing it out, those of us who did not know that this is how it works should learn it from the question. No, where's the problem? Let's try question number 7. Take your time. This might be slightly lengthy. Take your time. Again, 2018 question. Let's try to look at this. Guys, my sincere request to all of you, whenever a exercise sheet is floated 24 hours before the session, you must try and ensure that you are solving that exercise sheet before coming to the classroom. Okay, so please ensure you do that from next time onwards if you've not done it for this class and my last class as well. Okay, coming up is Varun's session on Friday. I'm sure it's going to be an amazing session where he's going to talk about probability. I'm not going to spoil this session by giving you these surprises and upfront over here, but attend that session. It's going to be very, very interesting. Let's pay attention. Gopal borrows rupees X from Ankit at 8% annual interest. Okay, so Gopal borrows X amount of money. Gopal borrows it from Ankit and at the rate of 8% annual interest. He then adds a value y to this. So he is now adding a value and making it x plus y and lends x plus y at 10% to Ishan. This was given to Ishan at 10% interest, annual interest. At the end of the year, after returning Ankit's due, the net interest retained by Gopal is the same as that accrued to Ankit. So what Gopal is doing, he's taking X amount of money from Ankit at a rate of 8%, adding Y amount of money to this and lending this entire money at 10%, and it repays the interest to Ankit at the end of the year, right? And what is the question saying? After returning Ankit's due, whatever is the interest left with Gopal is the same as the interest that was paid to Ankit. Is the same as that accrued to Ankit is the same, meaning that what was given to Ankit by Gopal that same interest is what he is also left with. So now understand this thing, that he will have to pay 8% of X to Ankit, and that particular value is nothing but 10% of X plus Y. That will be the interest that he will get from Ishan, and subtract the value that he is going to pay back to Ankit. Correct? So this will be the leftover interest with Gopal, and that is equals to the interest accrued to Ankit. So this equation has got every term in either X or Y. It will give you the value of X in terms of Y or Y in terms of X, right? So you can simply say 8X is equals to 10 times of X plus 10 times of Y minus of 8X. That's the equation that you are looking at. Now 16X is equals to 10X plus 10Y, and this is then turning out to be 6X is equals to 10Y, or X is turning out to be equals to 5 by 3 times of Y. This is one equation that we have until this point in time. Clear? Now go further. On the other hand, had Gopal lent X plus 2Y. So to Ishan, he was lending what? X plus Y. Now he is lending X plus 2Y. Had he done this particular piece to Ishan at 10%, then the net interest retained by him would have increased by rupees 150. So what was the net interest retained by him? He had charged 10% to Ishan and returned what? Returned an 8% on X to Ankit, and he is getting 150 more than the interest that was left with him. Now understand that the interest that was previously left with him was equals to the interest accrued to Ankit, correct? So 8% of X, and to that I will add 150. This was the value that he was retaining last time, and now he's going to get 150 more than that, right? So on your left hand side is also interest that he's retaining with him, and on the right hand side it was the previous interest plus 150. You just have to solve this equation. So I'm taking 10X plus 20Y minus of 8X is turning out to be equals to 8X plus 15,000. So that's the value that I'm getting over here. Now, if you solve this, you are going to get what? 2X plus 20Y is equals to 8X is equals to 15,000. Now, if you solve this, this is going to be 20Y minus of 6X is equals to 15,000. Now X is equals to what? 1.6. Okay, X is equals to 5 by 3. So 20Y minus of 6 times of 5 by 3Y is what the value of X is, 15,000 over here. 3 2s are 6, 10Y turns out to be equals to 15,000. Y turns out to be equals to 1500. If Y turns out to be 1500, then X turns out to be equals to what? 2500. What is the question asking you? Find the value of X plus Y. X plus Y is going to be equals to 4,000. That's the answer that we are going to get. Sir, you can subtract the two equations and get that directly. Yes, Aviral, there are several ways of solving a particular equation. You can do that as well. Absolutely not a problem. Any doubts, anyone? Probably slightly a lengthy question, but I believe if it was a 1 hour paper, this question was warranted on that paper. Again, it is just trying to confuse you by giving you too much of a data over here and trying to make you feel that the question is difficult. I very strongly recommend all of you, whenever you look at a question which is lengthy in terms of reading it, in all probability that's going to be an easier question. Okay, so don't leave a question just by looking at the length of the question. Any doubts, anyone? 30 seconds before we move on. Yes, Gokul, we can. Right. Try one last question for the day. Take your time. Acha, accrued to is the interest that he's going to take. Accrued to Ankit means the interest that Ankit is going to charge. That's all. Diksha, that's not correct. Think again. Ishan, that's not correct. Okay. Most of you have given me the correct answers. Let's look at this particular question. A person invests a total of 15 lakh rupees. A part of it was invested in a fixed deposit earning 6% annual interest, and the remaining amount was divided into two deposits of 2:1 earning annual interest of 4% and 3%. So basically what is happening is this 15 lakh rupees has been divided into two parts, and further one of the part is divided into 2:1. I look at this 2:1 ratio. I believe that part taking that as 3A and then saying that this is 2A and 1A is going to help you while doing your calculations. If you feel that this is unjustified, you have read the question before, solved it, and that is why now you are claiming this, I'm absolutely fine with this. Even if you don't do this, you are going to get the answers easily. That's not going to be a problem. Okay. Now this particular side is going to be 15 minus 3A, which is invested at 6%. At 2A, 1A is what you are looking at. So this is going to be 4% and this is going to be 3%. Right now, if the total annual interest income is 76,000, then the amount invested in the fixed deposit was how much? That's all what the question is. Now, there's nothing much to do in this particular question. You're going to charge a 6% of 15 minus of 3A, correct? And then 4% on 2A because you are looking at only the annual interest. And then the next is 3% of A. This should be equals to the interest of 76,000. The only mistake that I expect my students to make on this paper is write this equation and instead of putting 0.76 over here, you put 76,000. That's the bad mistake to make to my mind. Why? Because this 15, when you have taken in lakhs, this 3A is also in lakhs. The entire interest is coming in terms of lakhs. How will you make it equals to 76,000? Making it equals to 76,000 means it is 76,000 lakhs. If you understand what am I talking about, right? So that is what the equation will presume. So be very careful with such mistakes and don't mess it up on the paper. Okay. So 6 into 15, that's 15, 6 are 90, 6 3 are 18, 4 2s are 8 and 3A over here. And that's 100 taken on the other side. That makes it 76. Every term had 100 in it, right? So just solve this. 90 minus of 7A is going to be equals to 76. 7A is going to be equals to 14 and A is going to be equals to 2. Now, what was the question asking you? If the total annual interest was 76,000, then the amount invested in the fixed deposit. They've very clearly mentioned a fixed deposit over here. That means 15 minus 3A was the amount in the fixed deposit. So it is going to be 15 minus of 3 times of 2, which is going to be 9 lakhs. So 9 lakhs is the amount, or 9 should have been the answer to this question. Please be very careful while sitting in the paper. They very clearly mentioned that the amount in rupees lakhs. So please answer the question accordingly. I hope we all are clear with this. Any doubts, anyone, please let me know. Please do attend the session on Friday by Varun on probability, and post that we will have the sessions only on the next week. So next week, Monday, Monday, Wednesday and Friday are the sessions that we are planning to schedule. We will keep you informed on the community group. So those of you, anyone who is not a part of our community group as yet, can reach out to us at 9282442221, and we'll be happy to add you to that group.